let's take today one more class on AVL tree. So, what is that AVL tree? It is also called balance tree, right? It is also called balance tree. In shortly, you can also say that it is also balanced binary search tree. Binary search tree. Okay. So, for construction, of AVL tree, okay, we have to do the following rotation. We have to do the following rotation. So what are the rotations are here? You can see number one, LL rotation. So what is LL rotation? So that is a node. It's a very simple definition. I am coming into that one. What is that definition of the LL rotation here? A node is inserted, right? A node is inserted to the left subtree. Okay, left subtree of the left child of the pivot node, right? So I am coming to the point, what is pivot node, right? So let's take an example that here when we are explaining this concept, so this is coming to the discussion, rotation to make rotation to, what is that idea? Only after rotation if the node, pivot node is, if the pivot node is heavy. So here the heavy, okay, could be left heavy or right heavy. That is, left heavy means +1 and -1 respectively. Okay, right. So let's talk about the rotation, how it is performed, right? So one more things we should know about that, balancing factor for construction of the AVL tree, that is called balancing factors. What is that balancing factor? In short, we can say BF. It is the height of the left subtree, minus height of the right subtree, right? So what is that idea? So I am coming to with an examples. So we can see this graph. When I say let come to the example. So what is that example here? Let P is the pivot element and A is the left child. Right. So what is that idea? Idea is that let that this is called the left subtree of node A, and let this is called right subtree of the node A. So what is my idea? Idea is that this is 0 and this is plus 1. So how it is becoming plus 1 here? That is, this side should be heavy. If this side is heavy, no doubt, it should be, we should write here, this is called P. Now, this is called the left heavy concept. We can write here, what is this one? This is called the pivot node, and this is called the left child, and this is called the left child, and right, this is called the left child, and it is called the heavy, left heavy concept here. Right, this is essential for us to know. The example we are talking about. So what we have to do here now, what after that, I have to insert the node here. Insert a node to left subtree, to left subtree. So what will be happen that, so if you, so what will be happen that these will be becoming heavy? Yes or no? So if it is heavy, what I have to do? I have to make it is the same whatever there here, it is let it be there, and this figure how much it is there here, let it be there here, and little bit this is called AR, and this figure it will be becoming larger. So that. So what is that happening? Now this will be becoming plus 1 and this will be becoming plus 2. Now this is an unbalanced situation. Unbalanced situation or unbalanced tree, we can say. So what we have to do that, we will apply AVL rotation. So what is that AVL rotation? Is nothing but we have to rotate around the pivot element. Rotate around the, rotate around the pivot node. So what will be happening? If you are rotating, look at this picture here. So the idea is that this will be, A will be coming up, right? Little bit height will be also get. Now, and P is goes down, so this is called the rotation here. Make it is P here, okay. Make it is P here, and what happened to this concept? If you see this particular picture, this will be, and let me, this is called the PR, can have this is called the PR here, and this is becoming AR this side, AR, and the left side which you are finding here, now it is coming to this part. Because this is already heavy here, so we have inserted this point here. So you can see this particular situation. What happened? and in this situation it is becoming a completely balanced. So here we can write here 0 and this is the 0 here, right? So if the pivot node is heavy, so here heavy, left heavy or right heavy, that is plus 1 respectively. Balancing factor, height of the left subtree minus the height of the right subtree. This is what is about the pivot node concept. Now, if this is the case for the LL rotation, let me explain you. Let me explain you the second category. For this is called the left rotations.